have a 2-wire sensor. This is measuring resistance. There's no power here at all. It's just measuring resistance going back to the temperature control panel. So we have a measuring resistance, and it is telling us the temperature of this cavity of the mixed air temperature. So we have a outside air damper, return air damper, and a relief damper, giving us the mixing box chamber here. So
can you point out the dampers quick?
So the dampers here are up on top of the unit here. We have an outside air damper, a return air damper, and a relief damper. So those all operate off the same 0 to 10 volt signal. 0 volts being closed to the outside air, full open to the return air, and closed to the exhaust air. And there's a 24 volt power that powers up those actuators, along with a 0 to 10 volt signal that drives those actuators. So
okay, and we can get a look at the physical dampers that those actuators are controlling in here.
So up here we have our mixing box dampers, which consist of 3 dampers. We have an outside air damper, a return air damper, and a relief damper. Those dampers operate off of a 0 to 10 volt signal that drives those dampers between open and closed. It is a 0 to 10 volt modulating signal. There's also 24 volts that powers those dampers up. That is 24 volts AC. Inside the unit here, you will see the outside air damper. The outside air damper is normally closed. The return air damper is normally open. And on the back side here, which you can't see in this video, is the relief damper. Those all operate off the same 0 to 10 volt signal. So as one starts to open, the other one starts to close. We removed a few filters here to be able to see inside this unit. But this is what makes up the mixing box chamber. Here we have the PXC that controls that air handler. The 2-wire temperature sensor for the mixed air temperature comes back as an analog input to the panel. It is landed on point number 19 here, and it is a 2-wire. We have terminal number 65 and 66. So 66 is a common that's shared between input 19 and 20. And as you can see, we have a 2-wire here that comes back that measures that resistance. These are all programmable inputs and outputs. Some of them are strictly inputs, some of them are strictly outputs. On the right hand side here, we got a series of digital outputs. Those are dry contacts. And on the left hand side here, we have a mixture of analog inputs, analog outputs, and some digital inputs. So we can do 4 to 20 milliamps, 0 to 10 volts on the analog outputs. And then the analog inputs can either be 0 to 10, 4 to 20, or resistance, RTDs. On the bottom here, we have some strictly digital inputs. Digital input 25 through 28. Those 4 points are strictly digital inputs. All the other points here can be universals. They can either be analog inputs, digital inputs, or analog outputs, being 4 to 20 milliamp, 0 to 10 volts, or RTDs for analog inputs. The operator interface workstation. This is the software that runs the VAS system. We're going to show you what the point makeup looks like for the mixed air temperature. So we're going to take the mixed air temperature here on the graphic and drop it on the point editor, which is going to open up, and it's going to display the panel name, the address, and the point name itself. So as you can see, this is labeled BC A19MAT. It shows the field panel that comes out of, which is BC MEC3, and the address, which is point number 18 on here. So this point is not set to alarm, but if we wanted to set an alarm value in there, we could put a high alarm and a low alarm limit in that point. So via the building automation system, we can look at the performance and operation of this unit. We can do a controls check from the automation screen here, looking at the unit, making sure that it's operating properly. Currently this unit is in the unoccupied mode. So with it being in the unoccupied mode, the mixing box dampers would be closed to the outside air, open to the return air. As you can see, the fan is off right now, not delivering any CFM to the space. The heating valve is currently closed based on our mixed air temperature. If we were to come in here and do an annual check on this unit, we would check over the dampers, the heating valve, maybe look at some trends, look at the current alarms on the alarm screen, and just give it a once overall check, making sure that the dampers and the valves are working as designed. Do a few of the components found on this air handler. This is a air handler that has outside air dampers, mixing box dampers that consist of the outside air, return air, and exhaust air. We have an airflow station up above here that measures the CFM coming into the unit. We have a filter differential pressure transmitter here that tells us when the filters are dirty. We have an averaging mixed air temperature sensor. Up here are our mixing box dampers. We have a face and bypass damper here that modulates to maintain discharge temperature in the face and bypass mode. We have a manual reset freestep here on the unit also. We have a modulating heating valve that modulates, it's a three-way valve, so it modulates between open and close to maintain our discharge air temperature. We also have some freak drives over here, constant volume supply fan, and we have a freak drive on the return side. We also have a discharge temperature sensor here that measures the discharge going out into the space.